completing this potential energy part. After this, you'll be able to understand because we'll be starting fresh with capacitance. So at least capacitance you'll be able to gear up. Okay.
All right, ma'am.
So Q1 charge is there, Q2 charge is there, and they are separated by a distance of R. So we studied that potential energy is given by K, Q1, Q2 divided by R. Coming to the basics of potential energy, we have seen that potential energy comes in the system whenever you have interaction. Interaction charges should be present in order to interact. Two charges should be there, and if you think that they are able to interact with each other, interact as in you are able to see that they are able to exert forces on each other, so that will be considered as one potential energy. Okay, between two charges, one single potential energy. So class, can you tell me, out of all this, the system that is present in front of you, can you tell me how many potential energies can exist here? Like, what do you think is the minimum number of potential energies that can exist? In this figure, between two charges, one potential energy will be there, and the formula will be KQ1, Q2 by R. Just tell me the number by looking at the figure. No need to draw it or anything. Just tell me by looking at it. Yeah, just write it in the chat box. Between two charges, one energy will be there. How many energies will be there, class? Okay, Ali has answered. Rest of you? Three. Q and 2Q. They will form one potential energy. Correct? 2Q and minus Q, they are able to exert force. These are the two charges. They will form one potential energy too. Like this I was asking. Minus 2Q and minus Q, they'll form three, a third potential energy. Minus 2QQ, they'll form fourth. Are these enough? Or do you think more energies are there?
More.
Yeah, Ubaidullah, more?
Yes, I think diagonally.
Yes, very good. Diagonally, correct. Plus Q and minus Q are also able to exert. So this is the fifth one. And 2Q and minus Q are also able to exert sixth one. So total 6 potential energies are existing in this system. This is the first step. You have to identify how many potential energies are possible. Then calculate the net one. You have the formula K, Q1, Q2 by R. See, when I write down the net potential energy between this U1, basically what's the net potential energy? It is U1 plus U2 plus U3 plus U4 plus U5 plus U6. So when I add all of it, U1 will be CK, charge is Q, this charge is 2Q, divided by separation is A. Coming to the second one, look, this is a negative one. So we are going to put the negative because it is scalar. This is not a vector quantity that we have the separate mechanism to calculate the direction and everything. Here you don't have any concept of direction. So this will be minus, because of this, KQ into 2Q divided by A. Okay. Lee, can you tell me U3? Lee. Potential energy third. How should I write it? Lee?
Minus KQ minus 2Q by A.
Minus Q into minus 2Q. That will make it positive. So I can say plus K into Q into 2Q by A. Why did I write plus? Minus into minus is plus only. So that's what I have written. Okay. Coming to this fourth one. Ubaidullah, can you tell me? U4, how should I write it?
minus k q 2q by a.
Correct. Very good. This will be minus k q into 2q divided by a. All the four energies are completed. Now coming to the fifth one. Can anyone tell me the fifth one? Aisha, can you try? Fifth one. Yeah, Aisha Arif, try it at least. Put the things in the formula. Whatever you will not be able to tell, I'll help you. Say.
Minus K
Hmm.
Q
Yes.
and plus Q.
Yes. One more Q. Q into Q. We are not adding it. Remember, we are multiplying. Okay. So Q into Q, correct. And minus because this is negative. Okay. So it's actually like K into minus Q into Q. So minus K Q Q divided by
A.
not A. C.
A by
This is the diagonal. A root 2. A root 2.
A
C.
to
This side is A, this side is A. So this is actually acting as a right angle triangle. So the diagonal of the square will become A root 2. So here we'll have A root 2. Okay, Marwa, can you tell me for the sixth one?
Yes, ma'am.
Yes,
It's
try.
my minus 2q
Minus 2q.
or minus 2q
This is plus.
plus 2q.
That is into 2q. One thing you are missing here. What's the first thing that we write?
K
K. K into minus 2q multiplied to plus 2q. Divided by Marwa?
divided by A root 2.
A root 2. Very good. Correct. So that's how you have to write. Now your physics part is over. Just your basic mathematics part is left. Whatever you have to do is just simplifying this. Correct. So this I can write it as 2kq square by A. This will be minus 2kq square by A. This will be plus 2kq square by A. This will be minus 2kq square by A. What is this left? Here it is minus kq square by A root 2. And this is minus 4kq square by A root 2. Okay, class, the first 4 will get cancelled. This is getting subtracted to this. This is getting subtracted to this. We are eventually left with minus kq square by A root 2 minus 4kq square by A root 2. Directly also you can say minus 1 into minus 1 minus 4 is minus 5. But let's write it stepwise. Let's take minus kq square by A root 2 common. So if we write minus kq square by A root 2 common, from here 1 will be left. From here plus 4 will be left. What is 1 plus 4? 5. So what's our final answer? We can say the final answer is minus 5kq square by A root. So we didn't practice any questions on potential energy on that day. From potential energy of electric dipole, Muniba and I think Kausar has also joined. Yeah, Kausar and Muniba, you'll be able to understand this is a fresh topic. This was a continuation of the last class. Rest of you, please note it. And Muniba and Kausar, you also write it at least. Okay, please write it. We are just using the formula K Q1 Q2 by R. That is this question clear to everyone? Yeah?
Yes, ma'am.
Others?
Then why we are doing summation of all potential?
Here, net potential energy. How will you get the net potential energy? We have to find out the total potential energy of the system. So that's why we are adding all the potential energies. Okay?
Okay.
All right, please write it.
Ma'am, can you scroll?
Done.
Yes, ma'am.
See, when we have an electric dipole and we are calculating the potential energy of a dipole. So what happens is when a dipole is present, the torque tries to rotate the dipole. So there can be different angles, like, see, if this is it, let's say it is rotating it to some theta 1, or it is rotating it to some theta 2, like this, the potential energy will be present. So what was the relation between torque, dipole, and electric field? Can anyone tell me? Formula of torque. Formula of torque, dipole, electric field. Was there any relation which connected all of these three? No. If you don't remember that formula, then there's no point of doing potential energy due to dipole. At least tell the torque. Aisha? Muniba, do you remember?
Momentum into
PE
electric
sin
field.
theta.
Yes, Muniba?
PE sin theta.
Correct. P cross E, yes, Ali. P cross E, P sin theta. Momentum is different. That P is not momentum. P is the symbol for momentum also. So you're getting confused with that. Momentum is also P, dipole moment is also P. This is P cross E, right? So we say this is PE sin theta. Also, Aisha, dipole momentum is represented with a capital P. Here we have a small p. Now, when you write down the work done is torque dot d theta from theta 1 to theta 2. Now, what is this? See, whenever we have a variable work done, not variable work done, in the sense variable force. So, the formula of work done is force F external dot dr from R1 to R2. This is the whole formula. F dot dr is there. F dot s, dot product of force and displacement for work done. But when the force is variable, you integrate it from R1 to R2. F external dot dr is from R1 to R2. When you write down the rotational analog of it, work done remains work done, but external force, with the force which is acting in your translation motion, becomes torque. This becomes the external torque. D theta dr, which is the small linear displacement, this becomes the small angular displacement, which is variable. And so since you are using d theta, you integrate it from theta 1 to theta 2. This formula, I'm sure you must have done it in your class 11th also. So from here, we'll put the value of PE sin theta for torque, right? Torque, if you have torque as PE sin theta, put it in this main equation. So work done will be PE sin theta d theta, integrating it from theta 1 to theta 2. Now class, in integration we have studied, we take out the constant terms first and then integrate whatever is left. PE is a constant term, we'll take it out. Integral of sin theta d theta from theta 1 to theta 2 is left. Integral of sin theta is minus cos theta. So PE, this sin theta's integral, remember class, when you have integral of sin theta, it becomes minus cos theta, not just cos theta. So this will be minus cos theta. What are the limits? From theta 1 to theta 2. I'm writing this minus sign here, minus P. Now, how do we integrate? We put the upper limit first, minus then the lower limit. This is how we integrate. So, we have upper limit first, minus lower limit. What is this? This is the work done. Now, class, energies are never created, they are never destroyed, right? Neither created nor destroyed. This you have studied in your lower classes also. So what happens to energies? How do we have the energies? They just get converted from one form to another. Like if a fast moving ball is thrown upwards, entire kinetic energy gets converted to potential energy. So like this, here also the entire work done gets stored in the form of potential energy. Okay, in the form of potential energy. So what will happen? What will be the formula of potential energy? It will be minus PE cos theta 2 minus cos theta 1. Yes, if you want to write this as PE and cos theta 1 minus cos theta 2, that is also valid. Like PE, if you change the values, this negative sign will be gone. So it will be cos theta 1 minus cos theta 2. But class, don't learn both of it. Otherwise, you'll be very confused. Just have a habit of remembering only one. Also, one more thing, class. You just get only one angle in your question. Like only 60 degrees mentioned. So where is theta 2? Or let's say 30 degrees mentioned. Where is theta 2? In such a case, this means that theta 1 is already 90 degree by default. That will not be mentioned in the question if you see only single angle given. By default, this is hidden, which will not be mentioned in the question. Then how will we solve it? So C class, minus PE cos theta 2 minus cos theta 1. Cos theta 1 will be 90 degree. Right, cos theta minus cos 90 degree. Cos 90 degree is 0. So you will get this as minus PE cos theta. A, B cos theta is nothing but dot product A dot B. So potential energy will be minus P dot E if only one angle is given. Usually both kinds of questions come. So this is nothing usual that these kinds of questions come usually or that. In the board exams, these are also come and these have also been asked. So this is your derivation of the energy. And C class, the entire finally formula that we'll get is minus P dot E. Minus P dot E means minus PE cos theta. Cross product may we use sin theta or dot product may we use cos theta. Right? Is this derivation clear to everyone? Potential energy of electric dipole. Anything you want to ask?
Ma'am, why is it 90 degree?
This one here.
Yes, ma'am.
See, whenever the dipole is rotated, so this is assumed that one of the angle, like from the starting position that was chosen as 90 degree, the dipole has been moved to some angle. So there is no point of taking the other angle. So this angle from where it is starting, this is making 90 degree. So the dipole has been started from 90 degree. This is what's the meaning of it. Okay.
It is due to torque.
Torque will rotate it. Torque will rotate it. Angle is just the starting position. It has been rotated like this. Rotational work is being done by torque anywhere in your system. Okay.
Yes, ma'am.
The others also, I hope it's clear. Please write it. If in between you want to ask anything, you can ask. Please write it.
So in the beginning, it is 90 degree.
In the beginning, it's 90 degree. For that case, if you have two angles given in the question, just use theta 1 and theta 2. That means it's like this. This is not at 90 degree. But if it is given only one angle, like calculate the potential energy for 45 degree, nothing else is mentioned. It means it has started from line 90 and it is going towards 45.
Ma'am, can you scroll up? Ma'am, what is that external torque is equal to minus torque?
This one, see, external torque basically means a torque. See, when we say there are two kinds of torque that act in the system, one torque is the restoring torque. Restoring torque brings your body back to the mean position. Okay, its work is to bring it back to the mean position from where we started it. And then means like if you have shifted it here, restoring torque will try to bring it back to its original position. Then you have the external torque. External torque means the torque which is required to disturb your system, like the dipole was present. This time, when you are moving it towards something to a new angle, this is called the external torque. And the restoring torque will try to bring it back to the mean position. So they both are following the Newton's third law of motion, action reaction. That's why this is written as negative. Understood?
Yes, ma'am.
Ubaidullah, have you written this part?
Yes, ma'am.
Done?
Yes, ma'am.
Okay. See, just one more concept. Work done by this I have already told you. See, whenever you are asked to write about the work done by electric field, here also again it will be negative of the work done by external. We will do it in the form of question, then this will be better. Now, there are three cases which you should remember and which often come in the exam. When we have the formula, U is minus P dot E, which is minus PE cos theta. If dipole is aligned parallel to electric field, here the dipole is aligned parallel to the electric field. Theta will be 0. So you have minus PE cos 0 degree. Now class, cos 0 degree means 1. So this becomes minus PE. See class, this is the minimum value of potential energy. It is in negative. It's the minimum value. But negative, I've already discussed in the last class. Your bounded system is represented through a negative sign. Negative potential energy represents a very stable system as it shows attraction nature. Attractive forces are there. So your system will be stable. That is what is the meaning from the first one. This you should know. If they are anti-parallel, means dipole is kept anti-parallel to the electric field. This is anti-parallel. So here U is minus PE cos 180 degree. Cos 180 is minus. Minus into minus will be plus PE. So this is the maximum value of potential energy, right? Plus PE, highest value. But the system is not good. This is unstable system because it's a positive potential energy. In this part, just a second, class, I'm resharing it. See, in this part, yeah, theta, I hope the screen is visible.
Yes, ma'am.
Okay, all right. Theta is 90 degree. Straight away, you have U as minus PE cos 90 degree. Cos 90 is 0. There won't be any potential energy if the second angle is also 90 degree. Why? What is the meaning of it? The starting position is this. Final position is also this. It has not moved. No potential energy, nothing. Okay. Write down these cases, then we'll practice this question, and then I'll start with capacitance. Please write it from here. Also, class, regarding the assignments, only Ali and Marwa have submitted. Others also share. I wanted to discuss electric field as a gradient of potential, that assignment. It's a very good assignment and very good questions were given. Ali, I think the last question you were having trouble, and Marwa also. One question you people were getting stuck. So I was just waiting for Aisha and Ubaidullah. You also attempted. So that in the next class, we can have a discussion of the assignment first. Today, the assignment that I'll give you will be on potential energies questions. Okay, one question, one or two questions from potential energy I've given. Ali, I think you do the assignments in a hurry. Final answer nahi likhte ho, Ali. Just write down the final answers also. Okay, whatever trouble you have, that I'll discuss it. Other students, please, in the next class, I'll discuss the assignments directly. See, why it is positive? Because cos 180 is minus 1. Okay, value of cos 180 is minus 1. So it's like minus PE into minus 1, which is plus PE. Okay. Done. Does also. Have you all completed?
Yes,
Okay, let's practice the question then. Okay. This is an electric dipole. Dipole moment is given as 2 coulomb meter. It is placed in an external electric field. What's the value of electric field? 10 Newton per coulomb. First part says, see, you have to calculate the work done by the external torque in rotating the dipole from parallel to anti-parallel. Means what's your initial angle in parallel? What's it? Parallel में angle क्या होता है? We just did it class. Yes.
0.
Correct. 0, 0. Parallel, see. Yes, right. See, who is having confusion with 180 degree? Parallel means two things are aligned. Anti-parallel means one is in the opposite direction. Anti-parallel means just opposite to each other in direction. So 0 degree. Second one is two anti-parallel. So anti-parallel is 180 degree. Okay. So this is just like this. Two of them are exactly in parallel. So this is making 0 degree angle. You make this here, this makes it completely 180 degree. This is how you see. Here angle will be reduced to 0 degree. This is how you have to check. So see class, we have the formula of work done as minus PE cos theta 2 minus cos theta 1. See class, let me put the value. Minus dipole moment is 2, electric field is 10. Cos theta 2 means cos 180 degree minus cos theta 1 is cos 0 degree minus 20 into cos 180 is minus 1 minus what is cos 0? 1. So basically you have minus 20 into minus 2, that is 40 joules. Okay, this is basically 40 joules. Second part says work done by electric field. See, this was the external one. Electric field is a part of the system. It's internally. Electric field is related to the internal part. So electric field, as I told you here, it says that the work done by the electric field will be negative of the work done by the external force. So in the second part, you need not make any calculations. Work done by the electric field will be negative of work done by external. So it will be minus 40 joules. This was 40. This will be minus 40. Then the third part says calculate potential energy difference in part 1. Class, work done, if work done is 40 joules, can anyone tell me what will be the potential energy? If work done is 40, what do you think is the potential energy? The last step of the derivation. Yeah,
40.
when? 40. Exactly. Work done gets stored in the form of potential energy, na class? So work done will be potential energy. It will be stored in the form of it. So if it is 40 joules, it will also be 40 joules. Also, class, even if with this work done is not mentioned, what was the formula of potential energy? Minus PE cos theta 2 minus P minus cos theta 1. That's the same thing. Last part. Now look, this is what I was referring to. Calculate potential energy if dipole is placed 60 degree with respect to the field. Here you don't have any other angle present, right? So U is minus PE cos theta minus 2 into 10 into angle is 60, 60 degree. Cos 60 is half, 2 gets cancelled. This is minus 10 joules. Okay. Clear?
Yes, ma'am.
What about others? Kausar, Muniba, Marwa, Aisha. You're understanding?
Yes, ma'am.
Yes.
Okay, then write it. Write down this question. Then I'll start with capacitance. Done?
Yes, ma'am.
Okay, class, let's start with capacitance. Just understand the meaning of capacitance. What is meant by the term capacitance? Because see, once this is covered, this is completed, then we will not come to its meaning. We'll straight on be discussing the numericals, we'll be straight away discussing the questions. What is meant by capacitance? See, there is a device which is called a capacitor, which is inserted in most of the electronic devices, such as fans, electrical fans, or electric motors. Basically, there are certain devices that require a lot of amount of charge in the starting. Okay, at the very beginning, they require a high amount of charge. I'll write it also. They require a large amount of charge. Okay, in the starting, they require a high, great, huge amount of charge. But once they are started, afterwards they'll have a smooth motion. Okay, they'll just be conducting smoothly. Because then current will come into action and current will take over it. And current is a part of electrodynamics, that's not a part of electrostatics. So that we'll study current electricity. So what happens to such devices is that they require a very huge amount of charge. But charges, when you switch on the circuit, anytime, charges have their equal amount the whole time. That's why we have the concept of current. So what does a capacitor do? Capacitor, basically this is how a capacitor looks like. Okay, it stores a lot of charge in itself, lots and lots and lots of charges in itself. So all the charges are stored in the capacitor. And what does it do? When required, it gives all of these charges straight away at once. Okay, so what is a capacitor? Basically, this is how a capacitor looks like. This is a capacitor. So what does it do? It gives the charges. They require a large amount of charge. So capacitor gives all the charges at once because it was required at once. Whatever is required, it fulfills the demand. Okay, one more thing. A good example that you all can relate is you have the mobile phones with you at the home. If you switch it on, just notice when I switch on the flashlight, immediately the light glows. See, immediately the light glows with a lot of high intensity in the starting only, notice. In the starting, and then it smoothens. In the starting, it's a lot of amount of charge that glows. So basically, a capacitor is put in the mobile phone flashlight also. The flashlights of mobile phones, they have a capacitor. Have a capacitor. What does it do? It gives a very high amount of charge in the starting only, what is required. See, when your phone discharges, it's not just because of one kind of charge, one kind of reason. Battery weakens, apps are draining, capacitor weakens. That's how we have the finally battery coming to the lower percentage. And when you put the charger back, when you put your phone back to the charger, you plug in your device, it not only recharges the battery, it recharges the capacitor also. So that's why all the charges are again stored when you are charging your phones with the help of a charger. All the charges are stored again in the capacitor, and then again you use it in your flashlights multiple times you use it, but then your phone eventually discharges. Notice that whenever you click the pictures using a flashlight, phone discharges even faster. This is the reason, because the capacitor drains off. Or a very good thing you can understand capacitor through it. Capacitor is a device that stores charges. What all devices are there, or what is the name of a term whose charges can be stored, or which can store charges? A conductor. So you can, for your understanding, replace the term capacitor with the meaning of the term conductor. Conductor is what? Conductors are, you have the good conductors, bad conductors. Conductors basically allow electrons to pass through them. This is what we have studied from our lower classes. So if conductors allow electrons to pass through them, they will allow them to store also, because they will only allow the electron to pass their upper layer. Insulators will not. There won't be any single charge going in the insulator. No, that's not possible. But within the conductor, it's possible, because it's permeable to electrons. Or in your daily life, you must have heard somewhere or the other the term condenser. Condenser is not working. The tube lights condenser has been jammed off. The condenser of the fan is not working. That's why it's not rotating properly. Like this, condenser is off, condenser is not working. All these are just basically representing the capacitor. So what is a capacitor? A device that stores charges, and when required, it gives all of the charges at once, is called a capacitor. Then what is capacitance? Capacitance is its property. It's the ability to store charges. The capacitor has the ability to store charges. That ability is called the capacitance. Capacitance basically tells the value, how much charge can be stored at once, because it's the property. Like, look at this capacitor. Can you see? It's written 1000 microfarad. 50 volt is the potential, 1000 microfarad here. This one. This is the capacitance. Capacitance, from the term only, you can remember it's the capacity, how much charge can be stored. Is that clear to everyone?
Yes, ma'am.
Yes.
Okay. Now, coming to its formula is very easy, very simple. Basically, capacitance is the ratio of charge and potential. It's the ratio of charge by potential. This is its simplest formula. Till the end, we'll use this formula only. Whatever modifications will come from this formula only. It's like the parent formula. So Q is the charge, V is the potential, C is the capacitance. But one thing, class, by looking at the formula, isn't it like capacitance is directly proportional to the charge and inversely proportional to the potential? Doesn't it look like this, if you notice? Directly proportional to this, inversely proportional to this. But in reality, capacitance, it's independent of both charge and potential. Is independent of charge and the potential. Reason is that, see, formula of C is Q by V, and V has KQ by R as the formula. So when you put it, QQ gets cancelled. Ultimately, you're left with the radius and the constant. That's it. We'll see it in detail, this part, how to calculate it for a conducting sphere and all. And one more thing, class. If it is storing a large amount of charge in itself, the SI unit should have been straight away joules. Or if it is storing a large amount of charge, it should have been coulomb. For potential energy, if it is storing a large amount of potential energy, energy means straight away joule. But we don't have these units. There's a new unit which has been put in the name of the scientist. Farad we write. The symbol is F. Farad. That's how we write it. Is it clear till here to everyone?
For capacitance, it is farad.
Capacitance, it's Farad, yes. Okay. All right, then please write it till here. Then we'll come to the spherical ones.
Ma'am, it stores potential also.
See, the
Potential
charges
energy.
are stored, means it stores electric potential energy, not potential. This is potential energy. Okay. Because all the charges are present inside, so that potential energy will obviously be generated.
Should we write examples also?
Yes, Ubedullah. Just don't draw the figure. Just write down the rest of the points. Completed? Okay, then let's continue. See, the capacitance of a conducting sphere. Capacitance of a conducting sphere means if we are just talking about a sphere, that is, see, when we have the charge q, radius is r, what's the potential? What's the potential if this is given to you? Charge is q, radius is r. What do you think is the potential? Yeah, Ubaidullah, you tell me. Potential due to a sphere of radius r. Charge is q. We did only one formula for potential due to a point charge. Point charges can be replaced with the help of a sphere. Anyone else who can answer?
KQ by R.
KQ by R. Very good, Manipa. KQ by R class, simply you have this as KQ by R. Okay. Capacitance formula is charge by potential. Put value of V in this, means put the value of potential here. What we'll get? Capacitance will be Q divided by C. This will be KQ by R. This gets cancelled. This is R by K. That's why capacitance is independent of charge and potential. One thing. Second, you know, K is 1 over 4 pi epsilon naught. So 1 by K is written here. That will be equal to 4 pi epsilon naught. So we can say that capacitance will be equal to 4 pi epsilon naught R. So here, what is C? C is the capacitance. And R is the radius of the sphere. Radius of the sphere. Now class, if this same sphere is put in a dielectric material or a dielectric constant is there, then it will just become, see, if you remember, we have recently done, the other students have also completed this. Ali, we've already completed that long time back. Epsilon can be replaced with the help of K times K epsilon naught. So when we put in the value for the dielectric material, it will be 4 pi K epsilon naught. Let's say C dash, capacitance in some other material. This will be the formula. So R is again the radius, but K is the dielectric constant. Now class, there is just one special case that is mentioned in your NCERT. A line is mentioned that what if Earth acts as a conducting sphere? So you know the radius of the Earth, this is 6400 kilometers, which is 6.4 into 10 to the power 6 meters. So if this is the radius of the Earth and we put it here, 4 you already know, pi you know the value for 3.14, epsilon naught also you know, 8.85 into 10 to the power minus 12. Only R is the variable, no? So if I put the value of R as 6.4 into 10 to the power 6, the value See, all of these things will be put. Why? If Earth is acting as a conducting sphere, we will get the value 711 into 10 to the power minus 6 farad, which can be written as 711 microfarad. This is not very important. It's just mentioned, so you should also know. Okay, write it. Then we'll see some more things.
Ma'am, how it became K epsilon?
Ubaidullah, you were there yesterday in the backup class. Remember, we discussed epsilon by
Yes, ma'am.
epsilon naught is K. Okay, so in a material, when this is not known, when the K is, epsilon's value is not known, formula will be 4 pi epsilon r. So this epsilon has been replaced with K epsilon naught, which I've written it as K epsilon. Okay,
But in above, there is epsilon naught itself.
not this one. This is when the air is present. This is here the medium is air. This is different. If there is a different medium, what will be the formula? This will be the formula in a different medium, 4 pi epsilon r. This is for a
So
different
below
medium.
is for another medium.
Yeah, this is for a different medium. Okay, this one is for a different medium. This one. This one is for air. Okay,
Okay, ma'am.
please write it.
Ma'am, 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 what is dielectric medium in insulating?
Dielectric medium basically means an insulating medium. See, you have two types of materials or mediums. Media. One is a conducting medium, one is a non-conducting. Okay, dielectric basically is the non-conducting one. This one is a dielectric. Means where insulation is there. You can understand it better with the term insulator. Insulator because it's common for you.
So dielectric constant is for insulating mediums.
Yeah, usually these materials are insulating in nature. So, see, okay, I've written it here, no? Dielectric medium, this is insulating. Dielectric medium basically means where this dielectric constant is put. Dielectric constant is a value for that particular medium. But the type of medium, which can be conducting or non-conducting, is non-conducting out of these. Dielectric constant or dielectric medium. Dielectric constant is a value. Dielectric medium is the insulating medium. Means like your take any different substances which are insulators in nature. That is a dielectric medium. But this is not just valid for dielectric medium because you are already multiplying it with a dielectric constant for any medium whose dielectric constant value is known. You should just know the value of this dielectric constant. Okay.
Yes, ma'am. Can you scroll?
Sure, Aisha. Or if you have a question, Aisha, you can share it on WhatsApp also right now. Or after the class, you can get it clarified if it's a theoretical part. If it's a numerical, you can share the question right now also. But either share it in the chat box here or on the WhatsApp. Okay, I shall discuss this. Rest of you, can we move forward?
Yes.
Okay. See, capacitor is a device used to store charges. How can you, this is the example which we have already discussed. Now, how can you create a capacitor, or what are the requirements for a capacitor to be created? Basically, you require two conductors. Okay, this is one conductor and this is second conductor. You require two conductors, just oppositely charge them, and in between there should be a medium. This is how a capacitor is created. That's it. That's all. Okay. So two conductors having opposite charges, and it's preferable if dielectric medium is present between them. But this varies. This you will see there are variable cases for this. This is not the prime important thing. But if I change or make the shape of the capacitor specific, like if I, instead of taking these random shapes, if I take two parallel plates like this and connect them. So this is what is the most common one, which we represent like this, the parallel plate capacitor. Then you have spherical capacitors and you have cylindrical capacitors like this. They are present. So cylindrical capacitor is in the competitive exams only. Those students who are preparing for NEET JEE, you focus on this one. This is the formula. Spherical, I'll tell you this one. Concentric spherical one can come in the exam, that I'll tell you. Parallel one is the most important class. Parallel plate capacitors तो बहुत अच्छे से करना because it is important and it's the primemost thing out of all of it that I've to learn. Okay, what's the principle of capacitor? Let me tell you this. See class. Principle of capacitor basically says that if let's say I have a sphere, this has lots of charges in it. Okay, lots of charges. A very high amount of charge means a very huge amount of potential, right? Lots of charge, because potential is what? Potential is dependent on the charge. Potential is completely a property of charge. Charge into work done, charge into K divided by R, this, that. So lots of charges are there in this one. So potential is extremely high. But what about the capacitance class? Capacitance means ability to hold charges. When I say the capacitance of a particular capacitor is more, this means it can accommodate more charges, right? If I say capacitance is very less, means it will not be able to allow more charges to come in. Now this is so filled. This is so filled. If I want a small amount of charge, let's say dq to come, this will have trouble to fit in this because already lots of amount of charges have come. So this means capacitance is very less in this case because the capacity to hold charges, it's like seats. Seats have been consumed. No more seat is available for the charge like this. Capacitance is not mathematically dependent on potential and charge. But this way, when the potential is increasing, our capacitance is decreasing because of the theoretical reason, not mathematically. Mathematically, it's independent. But if I somehow decrease the potential, if this decreases, this will increase because the amount of charges will be less. So lots of capacity will be more. So basically, the capacitor says that, let's say these are parallel plate capacitors and I have put them on insulating stand so that the charges do not go off. What is this? This is the insulating stand. Insulating stand so that the charges do not drain off. One, I'm charging it positively. Okay, one, I'm charging it positively. It has a potential V. What I'll do for the second one, I'll connect it to the earth. So all the students who had the first classes, I think Ubedullah, you were absent in that class. Rest of you in the backup classes also we discussed earthing. It will allow all the electrons to drain into the surface of earth, and as a result of which potential becomes zero. So net potential, the overall potential decreases. So lots of capacity is increasing. Now more charges can be accommodated. So capacitance increases. That's what is meant by principle of capacitance. It is saying capacitance of a conductor can be increased by how? By bringing an uncharged. By uncharged, net charge is zero. Net potential is zero. So uncharged, earthed. Earthed means the process of earthing has been done. Earthed conductor near it. Did you understand it till here? Everything till here? All of you? Yes or no? Apart from Ali, Aisha, Marwa, Muniba, Ubaidullah, clear?
Yes, ma'am. Yes, ma'am.
Ubaidullah, what about you? Hmm? Ubaidullah, you there?
Yes, ma'am. This is formation of capacitor. This conductor
Capacitor.
one, conductor two.
Yes, capacitor. Two conductors, charge them oppositely, capacitor is created. But standard way, we have the parallel plate capacitors, which are most applicable. Okay, please write it down.
Ma'am, second point means that there should be insulator inside conductor.
Yes, yes, between the two conductors, so that charges do not drain off in the medium. If it is insulated, then only no charges will be sticking at their place. If this is also conductor, then charges will go off.
Ma'am, here each of them will have dielectric.
What?
Each of them will have a dielectric medium. Yeah.
No, no, dielectric medium will be between them. Like here. Like this, between them. This is the dielectric medium. If this is not dielectric means insulating. If this is not a dielectric medium, what will happen? Conductor will allow the charge to come here. So like this, charges will come. Right? The property of capacitor to store charges. How the charges are transferred is through the process of induction, which we have discussed. I think you have missed it. One plate is positively charged. By induction, other plate becomes negatively charged. It's not that charges move within this. This is a dielectric medium. Okay.
Yes.
The rest of you, as you are completing, you can start leaving. Aisha, you just stay for your doubt. Rest of you, you can leave if you have completed it here. Okay. From the next class, we are left with parallel plate capacitors, energies, forces, some things are there. We need 2 to 3 more classes, but no, not 2 to 3. I think 2 more classes are enough. That will complete the chapter. Okay, class, then rest of you can leave. Thank you so much. Goodbye.
And this V and C is potential and capacitance.
Where?
This V and C.
Yeah, potential and
V decreasing.
E is potential, C is capacitance. Aisha, what was the theoretical
Yeah.
doubt you were saying? Yeah, Ubaidullah, done?
So potential and capacitance is inversely proportional.
See, they are not inversely proportional mathematically. But if you look by the definition, when potential is high, capacitance will decrease. Okay. This is not because the formula is Q by Q. This is not because of this. They are inversely proportional coming because of the theoretical reason and the definitions and the ability to hold charges. Okay, Ubaidullah, did you understand? Done, Ubaidullah? Yeah, Aisha, what was the theoretical part you saying? Okay, Ubaidullah, you can leave. Thank you, Ubaidullah. Yeah, Aisha, what was the theoretical question you were saying?
Theoretical and numerical, sorry.
Okay, you've edited it. Okay.
Yeah.
Yes. Let me discuss that with you. Wait. Okay, Aisha. Here it says two charges are present. Q is present and minus 3Q is present. Okay. And they are separated by a distance D. Where should a third charge be placed such that it will not experience any force? Means, let's say there is some charge, which is, I think they have already given, no, 2Q. So let's say 2Q is somewhere here. We don't know what is its value. Let's say here. It is X at X distance from Q. So what will be this much distance, Aisha? This leftover distance? Can you tell me?
D minus X.
D minus X, exactly. This will be D minus X. Now see, let me name the point. Let me say this is A, where charge is placed. This is B, where minus 3Q is placed. Here, let's say this is the center N. Okay. Now, whenever the net force is 0, the point is a neutral point. Okay. This point is called a neutral point. Now, neutral point means the net force here will be 0. Okay, net force or electric field, both of them. The same question can be replaced with the term net electric field is 0. The same question can come with it. Net force is 0. Basically, we can say that what is the force? Let's say F1, the force due to these two. What is the force? K Q into 2Q divided by x square. The force is K Q1 Q2 divided by R square. Will the force 1 between Q and this 2Q, A and N, will it be this, Aisha?
Yes, ma'am.
Similarly, can you tell me the force F2 between N and B?
KQ minus 3Q.
No, first of all, this is 2Q. So it will be 2Q. Second, you take the magnitude. Remember, I told you.
Oh, yeah, 3Q.
So it will only be into 3Q divided by D minus X whole square. Net force is 0 means, look, net force is 0 means your F1 plus F2 is 0. Okay. So here F1 will be exactly equal to F2. Why? Because then only the net force is 0. If I am pulling this from this side with the force F and I am pulling this with the force F, then only this will be static and not moving. Then I can say here in this case the net force is 0 when both the forces are equal, right?
Yes, ma'am.
So we will equate these to k into q into 2q by x square is equal to k into 2q into 3q by d minus x whole square. So see, k gets cancelled, q into q. This 2 gets cancelled. We get 1 by x. I'm taking the root because this will be x. Here only 3 is left. It will be root 3 by d minus x. Did you understand the step?
Root 3.
Let me rewrite it. What are we left with? 1 by x square is equal to 3 by d minus x whole square.
We can also like cancel the charge, like q and q.
Yeah, q and q will not be cancelled. See, they are equal from here. If I shift it here, it will be q by 2, q by q. You have kq on one side. Other side you have kq. Will this charge not cancel it?
Yeah,
This
yeah.
charge will come in the denominator, no? So it will be cancelled.
Mhm.
Did you understand this step or should I repeat
Yeah,
it?
yeah. I did.
Got it?
Just,
So see,
yeah.
when I take the roots on both the sides, okay, on taking the roots, 1 by x will be root 3 by d minus x, right?
Like to find the roots, like after we like cross multiply, we use like the quadratic equations to find the roots.
No. I have x square. I am squaring. I am taking this as half and this as half. Why? Because when x square will be to the power half, this 2 will be cancelled and I'll get x. That's what I've written. I have taken roots on both the sides.
Next one.
Whenever you have square, no, and you want to reduce the equation, you always take a root. See, whenever I write root 4, then you quickly tell me it's 2. Why do you tell me it's 2? Because it's root 4 to the power half. Correct. So
Next one.
this is the same thing here. We have actually taken the roots on both the sides because they are getting squared. Why have I taken this? The reason for taking the square is root is here something is getting squared. Like if I give you x square is equal to d minus x to the power whole square. Will not the square be cancelled from both the sides? Why?
Next one.
Because the roots and roots will be cancelled. Okay. So this is the reason. But 3 is not a number that could be solved. If the question would have been 4, many of the questions have this. 1 by x square is 4 by d minus x whole square. If I was left with this, Aisha, then I would have written 1 by x is 2 by d minus x.
Next one.
So root of x square is x, root of 4 is 2, root of d minus x square is d minus x, root of 1 is 1. But right now the value is 3. So that's why this is getting highlighted. Because root 3 is root 3 only means root 4 could be written as 2. Root 3 is in decimals. So I'm leaving it here. When you cross multiply now, it will be d minus x is equal to root 3 into x. Yeah.
Yes, ma'am.
So you can say d is equal to root 3x plus x.
Yes, ma'am.
So x, if I take common here, I'll be left with root 3 plus 1 is d.
Yes, ma'am.
So x will be d by root 3 plus 1. Got it? Basically, Aisha, take the net force, equate both of them, and then get the value of x. Now I have x is means x was this. So this 2q, it is saying no, where 2q should be placed. It should be placed at a distance of d by root 3 plus 1. Got it?
Yes, ma'am. Can we
Okay.
like also use
Yeah.
quadratic equation?
There is no need here. Like right now, there is no need. When you use quadratic equation, when you have a quadratic equation, right now there is no quadratic equation. Like
Now,
3
if we cross
plus,
multiply this, we'll get quadratic equation.
no, you won't get. How are you? Quadratic equation means equation has the power 2.
And this
Okay,
has
you're
no
saying
power.
here. You're saying here.
Yeah. Yeah.
If Then also you'll have to expand it. This will be, see, this will be d square plus x square minus 2dx divided by x square is 3. So this
3x
will
square.
be equal to 3x square.
I use the root, like I use the quadratic equation formula.
No, quadratic equation is valid for the equation. When like this equation, yeah, here it will be valid because this is a quadratic. I removed the root because this solving was easier. In one line you will get the answer. Here again you'll have to apply. See, this will be d square minus 2x square minus 2dx. Yeah, here you can apply the formula. You will get the same value, but it will be very lengthy. You'll have to use that formula, minus b square,
Minus b.
yeah,
Yeah.
under root 4 AC1, right? You can use that, you'll get the same answer through it because here a quadratic equation will be formed. But try to use this one because here it's 3.